Okay, hello, good morning, everyone. So we are in the midterm period right now. So this will be the first, what do we call this topic of the period for the subject CR and DR. So uh, first of all, thank you po sa mga greetings again from you from sa aking birthday, and thank you, God bless. Okay? So, warning lang, medyo lisod siya sa buton. Naglisod yung sabot sa. I had a hard time understanding the different uh, topics, the new information, because dapat kani siya is more on the computer side na magud siya. So it's not on our, what do you call this, on our field of view ba kumbaga. Okay, so please bear with me. If you have any questions about this, if you have something to clarify about the topics, you can message me, and I'll try my best to explain it to you. Okay, so kanisha again, nahirapan ako what do you call this, intindihin yung mga topics, but I will try my best to explain it as, uh, as, as easy as I can. Okay, so we will be discussing the image acquisition on both CR and DR. So in this lesson, I'll be discussing how the images are extracted from CR, DR, and using the CCD and CMOS. And of course, I'll be discussing how images are extracted from the PSP plate sa cassette for DR, and also lookup tables, histograms, smoothing, edge enhancement, and so on and so forth. So without further ado, let's start. Start with the raw data acquisition. So how is the raw data acquired? As the name states, raw data is acquired or received by the reader, no, or the computer. So for imaging of the patient to start, the patient should be positioned according to the anatomy of interest, of course. So kung di na to siya i-position, how will we be able to acquire the image? Okay? So kailangan natin i-position. So if the request for the patient involves the chest, so of course you need to position the patient according to the anatomy of interest or according to the request given to us by the doctor. Okay? And since DR uses no cassettes at all, since DR uses no cassettes, all procedures are done using the radiographic table or chest board, which house a permanent array of miniature radiation detectors. So in direct radiography, we do not use cassettes anymore. We use the, what do you call this? Cassetteless man siya. So the detectors na radiation detectors na tawag sa iyahan. Okay? So the patient is either positioned in a chessboard or in a table. Okay, so it decreases the flexibility compared to CR na. With cassette, we can position the patient with more mobility and flexibility. Compared with DR, it's either on table or in the vertical grid or chessboard. Okay. On some systems, the field size for each view in a series is preset by the quality control technologist in consultation with the manufacturer upon installation. Okay, so in direct DR, since it's a preset na, you cannot increase the collimation or decrease the collimation. Okay, so this prevents any tighter collimation by the radiographer on smaller anatomy such as for pediatrics, and which will increase scatter radiation. So the more you increase the size of the field or the field size, the more scatter radiation will be generated. So there is also no ability to split fields for multiple views, and there is little mobility with the receptor plate. So there are a lot of disadvantages, for when we cater direct radiography. Okay, so first of that is, again, we are not able to collimate because preset na ang collimation for each body part. So kunwari, we are going to mag-x-ray tayo ng bata. Okay? So if ang preset na gamit or na-install ng quality control technologies is for adult, you can no longer collimate the field size into the desired size because it's preset na nga. Okay? And if pediatric ating patient or bata ating patient, the scatter radiation or the patient dose ultimately is increased for the child because again, the field size is big. Okay? So dapat manggod, when we x-ray the patient, field size niya is appropriate for the size of the body part. So since again, we are imaging, for example, a child, and of course, kung i-compare ninyo ang, for example, ang kamay ng adult and a child, of course, mas malaki talaga sa adult. And if the preset installed by the QC technologist is for an adult, no, that means for the child, malaki talaga yung field size, okay, which will increase the dose, which will increase scatter radiation and ultimately the patient dose of the child, okay. And also another disadvantage is in sometimes ang good, pag magbigay ng request ng doctor, the doctor asks for multiple views, okay? For example, sa chest PA or chest lateral. Chest PA and chest lateral, I mean. So there are two views, okay? So, pwede yan siya for children, pwede yan siya multiple views in one radiation detector or in one cassette, okay? So, position your patient and expose, okay? Then, you move the patient to the left to the other side and then expose na naman tayo for another view in one cassette. Okay, so that is what we call multiple view. Okay, two views or three views in one cassette. So since we are using direct radiography, we cannot do that because again, naka-preset na yung field size. So it will be more tedious. No, it will be more laborious for the technologist because again, imbis na maisa mo na lang yung two views in one cassette or in one detector, you have to expose one time and then expose for another one for the views to be seen in the monitor. Okay, so this the DR has little mobility with the receptor plate. Okay. Okay, so here we have another example. No? This time it's the hand. Okay, so what I'm trying to say from the previous slide. So, for this example, this one is, for example, yung patient is an adult patient. So, the field size is this one. Okay, yung light na ma-emit ng what do you call this? No, ng X-ray tube house. No, that corresponds no to the area of which the X-rays will interact no, on the cassette. Okay, for example. Okay. Now, if this is an adult hand, this will be, for the DR, ganito ang kanyang field size. So if the patient now is a child, no, so this hand will become smaller. So that means the field size is not necessarily increased, but the area where the X-ray will interact will increase. Okay, so that means if there is a greater area in which the X-rays will interact, no, that means more scatter radiation, no. Now hindi siya anatomy, ang matamaan ng X-ray. Okay, to simplify things, if the X-rays interact with the larger portion of the cassette na hindi siya anatomy ang interact niya, that means scatter radiation will increase. Okay, so with that being said, the patient dose to the child will increase and also scatter radiation first will increase and then patient dose na po will increase. Okay, and then in this second picture, as you can see in one image receptor, there are 4 views. Okay, for example, 4 views ni siya. Okay, you cannot do this on a DR because again, naka-preset na ang collimation for each. So for example, in DR, for each radiation detector or for each receptor plate, isang image lang ng hand ang malagay mo doon or ma-image mo. Unlike sa CR that it has an increased mobility, increased flexibility, you can do 4 views in one image receptor. Okay, so that's what I'm trying to tell. So since it is awkward to remove the DR grid and risks damaging it, usually all DR procedures are done bucky or with grid. So the disadvantage of using grid manggod, no, is it decreases, no, it increases, I mean, increases patient dose, although it has an advantage of creating a better quality in image, okay? The contrast is nice, okay? The image quality is good, okay? But in the expense of providing increased patient dose to the patient, okay? This may be largely responsible for a strong tendency to perform all procedures, including distal extremities, using the automatic exposure control or AEC. Okay, so when we so the arm good, you cannot you can, okay, take the grid out of the receptor plate, but it can be damaged. So medyo, since the receptor plate is worth millions, no? So it would be what you call this, risking, no, you'll be risking damaging it. Okay, so di na lang natin na siya tanggalin, di na lang natin tanggalin, and then we'll do every single examination, no matter what the anatomical part or thickness, in bucky or in grid, which results to increased patient dose for the patient. Okay. The use of grids and AEC both limit positioning and require exact alignment of the X-ray beam. So with AEC manggod or automatic exposure control, the this device automatically terminates the exposure. So this will require dapat naka-properly positioned ang anatomy of interest, and of course naka-align si X-ray beam to the anatomy of interest. Okay? So this will reduce the mobility. No, mahirapan tayo. This is one of the big disadvantages of DR because we are using grid, which at the expense of the patient increased ang kanyang patient dose, and AC limited ang positioning, limited mobility, okay, for the machine. I mean, limited ang mobility ng the system itself. Okay, so exposure levels are increased for distal extremities, which must be done with a grid technique. Although distal extremities mango, they do not require grid. Okay, so DR, since we are not able to remove the grid from the receptor plate, so we are going to use we're going to x-ray the patient using grid na lang yun because, again, di man natin siya matanggal ang grid. So this will result to an increased patient dose sa patient. Okay? On the other hand, since DR operates at a consistent speed class for procedures, radiographers are more confident when setting manual techniques and have less tendency to use higher technique than they think necessarily. Okay? DR has been shown to suffer less frequently from those creep issues than CR. So the disadvantage of DR is lesser flexibility, lesser mobility, and you have to use the grid and AEC, which increases patient dose. So to compensate for that, we can still manually increase or decrease the technique in order to compensate for the increase in patient dose. So of course, if we're going to use a grid or AEC, which increases patient dose, compensate natin siya sa technique, which we will decrease in order for it na ang patient dose na lang sa patient is what do you call this? Equal compared to CR kasi compensated nga ang kanyang technique. Okay? So, while DR is more efficient and consistent, CR offers more adaptability for positioning and technique. Okay? So, DR, lesser patient dose, but mahirap siya. Okay? It's difficult to position, it's difficult to maneuver the patient because yun nga, sa table lang siya and sa vertical grid lang pwede ma-position, and CR offers more adaptability for both positioning and technique. So with the use of cassette and computed radiography, we are able to position the patient seamlessly. Okay? Easy ang kanyang pag-position sa patient. And of course, we can still control the technique. Same with the DR. Okay? So now we go with image formation in both DR, indirect DR, and of course a CCD and CMOS. So how is data extracted from the detectors and transformed into an image? Okay, for direct radiography, we have this, what we call an active matrix array, or AMA. So this is an example of AMA, which we'll be discussing in a little while. Okay, but first we'll go discuss with this one. Okay, so most of the square area of the Dexel is a thin semiconductor layer that is sensitive to X-rays or light. So as you can remember, I have discussed this in the prelim period. Okay, this one Dexel, ito siya, one Dexel yan siya, is parang a small unit of the active matrix array. So a collective number of thin Dexels, okay, this one Dexel, 2, 3, 4, 5, 6, 7, 8, 9. So 9 by 9, 3 by 3 na, sorry, 3 by 3 na Dexel can create an active matrix array, but it's not limited to 3 by 3. It can be 4 by 4, 11 by 11, and so on and so forth. Okay, so going back, this area here, the Dexel detector surface, is the capture area for detecting radiation. So the larger the area as a percentage of the whole square, the more efficient the Dexel will be in absorbing X-rays or light. Okay, so the more, what do you call this? The larger the size of this area of the Dexel detector surface, the more efficient the Dexel will be in absorbing X-rays or light. So the larger the area here, the more absorption will occur. Okay, it will be more efficient in absorbing X-rays. Okay, however, the percentage of the square devoted to the semiconductor detection layer is called the Dexel's fill factor. Okay, one of the current limitations on Dexel size is that TFT and capacitor do not get smaller in size along with the overall Dexel. Okay, so diba, as I have said in the prelim period, we have what we call a fill factor. Okay, so the more your Dexels get smaller, the fill factor decreases. Okay, when we say fill factor, manggod, it is this area here. Okay, so of course, if you're going to minimize the Dexel, the Dexel detector surface minimizes because the TFT and the storage capacitor does not decrease with it. Okay, so the more you decrease your Dexels, your TFT and storage capacitor, di sila mag-decrease in size, the lesser na ang fill factor ng iyong Dexel detector surface. Okay? One of the current limitations on Dexel size is the TFT and capacitor do not get smaller in size along with the overall Dexel. A higher fill factor, manggod, provides both higher contrast resolution, or SNR, signal to noise ratio, and better spatial resolution. So with a higher fill factor, your image will have better recorded detail, and the shades of gray will also be increased. Okay? Therefore, smaller Dexels have a lower fill factor or less detector surface area, which then necessitates an increase in radiographic technique along with higher patient dose. So, smaller na nga yung Dexels, yung Dexel detector surface, sorry. Okay? Lesser na ang fill factor, and because of that, you are going to increase the radiographic technique in order to attain acceptable spatial resolution and contrast resolution. Okay, since smaller man ang ato ang fill factor, again, it will necessitate us to increase radiographic technique, which will in turn increase radiographic patient, which will in turn increase patient dose, no? And this is bad for the patient, of course. Okay, so in one corner we see a microscopic capacitor. Okay, this is the heart of the Dexel. This one, the storage capacitor. For it is the Dexel's ability to store electric charge, okay, that makes direct capture imaging possible. Excuse me. In the opposite corner, we see the thin film transistor, which acts as a switching gate to release electrical charge when the Dexel is read out. Okay. So yeah. So we have the TFT here and the storage capacitor here. So once the Dexel detector surface detects the X-rays or light, X-rays lang siya, okay? X-rays, sige lang, explain ako on the next slide. Ayan. So this one is, what do you call this? Parang cross-section view of this area here. So this is a bird's eye view of the Dexel, and this one is the cross-section view, okay? This slide siya on half, okay? So a thin 1 millimeter layer of semiconductor material is, in this case, is the amorphous selenium. This area here is the amorphous selenium. Okay, it's used to convert radiation energy or radiation into electrical charge. So again, di ba sa direct radiography, it's called direct because hindi na kailangan ng scintillator, no, in order to convert X-rays into light and then light again to electrical charge. Okay, so dito sa direct radiography, direct na siya, X-rays to electric charge. Okay, X-rays or light rays, depende pa, penetrating into this layer of selenium ionize its molecules. Okay, so we know previously as taught by you, as the teachers have taught you that during ionization, the product is an ion pair. Okay, one is the electron and the other is the positively charged atom. Okay, so this ionization of these amorphous selenium frees up an electron. Okay, it will free an electron from the molecule or atom. Okay, so once an electron is freed, therefore, ang mabili na lang sa atom is the ang mahitabo sa atom, ang mangyari sa atom, it will become a positively charged atom. Okay, since it lacks an electron. Okay, due to the ionization event. Each ionizing event creates an electron hole pair. Okay, so electron hole pair, ion pair, same lang po yan sila. Okay, so si electron hole pair comprises of both the electron and the positively charged atom. Consisting, it consists of the freed electron and the positively charged hole. It's called positively charged hole because, again, nabakantehan siya ng isang electron. Okay, it lacks one electron. It leaves behind in the semiconductor molecule that is the gap in the molecule where an electron is now missing. So, yun nga. Again, for the ionizing event, it will create an electron hole pair on an ion pair. Okay, so one is the electron and the other is the positively charged atom. It's called an positively charged hole because nabakantehan siya ng isang electron. Okay, next. The top electrode in the diagram is an extremely thin conductor layer with a positive charge placed upon it. So this top electrode is positively charged. Sorry. This charge attracts the freed electrons so that they drift upward. So yung freed electron, since opposites attract, di ba, positive and negative will attract, and since your top electrode is positive, therefore your electron will drift upward because it is attracted to its positive charge. Okay. At the same time, a negative charge placed on the Dexel electrode, which is here on the bottom part, okay, below, causes the positively charged holes to drift downward. Okay, so since it is negatively charged, your positively charged hole will get attracted to this area here. So that means magbulag na sila or maghiwalay na sila ng electron, which will move upward, and the positively charged hole will move downward. Okay. The net result is the positive charge built up at the bottom of the semiconductor, which is stored in the capacitor. So, as a result, this positively charged electron, since it's positively charged hole, will drift downward and attracted to the Dexel electrode. And this charge here, this positively charge, will then be stored in the storage capacitor. Okay? Yun siya. And then, a 9-Dexel station of the active matrix array is shown to the right-hand side. A network of data lines and gate lines crisscrosses between the Dexels. Gate lines are controlled by the address driver, and which controls order in which the Dexels are read out. Okay, for example, in this picture, the data lines are the vertical lines, and the gate lines are the, horizontal lines. So as I have said a while ago, gate lines are controlled by the address driver. So this is the address driver. It controls the gate lines horizontally. And then the data lines is the vertical ones. Okay. So when the bias voltage along these lines changed from -5 to +10 volts or +10 volts. Okay. So diba, as you can remember, in each Dexel, it stores the positively charged hole. Okay. So that is why +10 volts yan siya, because of the storage capacitors positively charged na mga holes na nakastore here. Okay, so once that once enough voltage is stored in the storage capacitor, it causes the TFT gates to open up sequentially and dump the stored up charge from each Dexel in succession. Okay? So once the storage capacitor senses na, okay, 10 volts na ako. Sorry. Once the thin film transistor senses that the storage capacitor changes from -10 to +10 volts, it will open up. It will switch open so that the storage capacitor will then release the positively charged the volt, okay, and then towards the amplifier in succession na siya mag-read out niyan siya from here and then here and then here, okay. So release of 10 volts, 10 volts, 10 volts, and then directed yan siya lahat towards the amplifier. Okay, so again, it is in succession, not all at once. Okay, so pag start dito, and then dito na naman, and then dito na naman, hindi siya all at once ang pag-release ng voltage. Okay, for each particular TFT, the change in voltage causes a channel of conductivity to be opened up along the semiconductor material. Okay, so since nag-change naman tayo ng voltage from -5 to +10, no, a channel of conductivity will be opened along the semiconductor material, which is this area here, the fill factor or the Dexel detector area. Okay, the charge flows down a data line to an amplifier which boosts the signal before sending it through an ADC into the computer. Okay. Yun siya. Okay, so once the voltage goes into +10 volts, the thin film transistor opens, and then the voltage goes along the data lines. Okay, so sa data lines sila magpunta. Okay, so the question is how will the charges here travel towards the thin film transistor? So again, di ba, as I've told you kanina, due to this change of voltage, your semiconductor material will be a channel of conductivity now. So it will conduct now electricity because it is a semiconductor. Okay? So pag na-change ang kanyang properties into what do you call this? Yung rubber, wait lang ha, okay, so I'll explain it again. So since the storage capacitor, pag mag-change niya siya into +10 volts, it will travel towards a thin film transistor through the semiconductor material here. Okay, so we all know that a semiconductor material behaves as either an insulator or a conductor. Okay, that's why it's called semiconductor. So once the voltage increases to +10 volts, in order for the voltage to be carried from this area towards the thin film transistor, the change in voltage in the semiconductor material here causes a channel of conductivity. So that means it will now conduct electricity or voltage. Okay, so since it now conducts voltage because of the +10 volts na nasa storage capacitor, the voltage here will travel from this area through the semiconductor towards the thin film transistor and towards the data lines towards the amplifier. Okay, so once the voltage has reached the amplifier, it will be, as the name states, amplified. The voltage will be amplified so that it can now travel towards the computer through the ADC. Okay, so from 10 volts, amplify siya into an increased number. Okay, so that after that, it will travel to the ADC, which will convert the analog signal produced by the amplifier into digital signal, and then towards the computer na yan siya. Okay. Now, for the indirect direct radiography, so this involves the amorphous silicon and cesium iodide, gadolinium oxysulfide na mga scintillators. Okay, so let's go into detail. This phosphor screen scintillates or fluoresces when exposed to X-rays, emitting light that will strike the TFT detectors. Since light is normally emitted isotropically in all directions from a turbid or powder phosphor, which reduces image resolution, a method of forming vertical crystalline channels, such as this one, okay, in the cesium iodide layer or the cesium or the what they call it, gadolinium oxysulfide. Yeah. forming vertical crystalline channels in the sodium iodide layer was developed such that the crystals lie vertically, forming light channels that confine dispersion of the light somewhat. Okay. Nonetheless, the resolution achieved is still not as good as with a direct conversion system in which electron holes drift directly downward to the TFT detector. So, okay, explain ko. So once X-rays interact with the scintillator again, since it scintillates, no, scintillator nga, it will produce light. Okay, so some of the crystals used for scintillators are sodium iodide and gadolinium oxysulfide. Okay, and they are created in a crystalline form in a vertical orientation. Okay, so in order for the light to be channeled directly towards the amorphous silicon or the TFT detectors, okay? So that vertically oriented siya so that the light emitted by the scintillators will go directly towards the TFT detector. Hindi na siya pareha nung turbid na phosphor or powder phosphor na kung saan-saan pa siya magpunta. With this one, the crystals guide the light towards the TFT detectors. Okay? Yeah. And then, the light from the scintillation layer is then directed towards to the detector elements in the active matrix array below. Okay? By using amorphous silicon as a detector element, these DEXELs effectively become photodiodes which convert light into electrical charge. So, sa indirect DR din, meron din silang TFT array, active matrix array, okay, in their detector element. So, since they are in amorphous silicon form, they become photodiodes. Okay, ang mga detector elements here. Okay, so the detector elements will become photodiodes which convert the light produced here into an electrical charge. This charge is stored on a capacitor and released when the TFT gate opens for the DEXEL to be read out. So same lang sila nung direct radiography. Okay, when it comes to the detector element. Okay, but this time we are using amorphous silicon. Okay, so when the amorphous silicon detects the light, no, in the detector, the light is converted into an electrical charge, okay, which is done by the photodiodes within the detector element. Okay, and then the electrical charge again is stored in the capacitor, and then we will wait for the voltage to be on the appropriate amount, and then the TFT gate opens na naman for the DEXEL to be read out. Okay? So for the CCD and CMOS na what we call this detector, when light photons enter the silicon layer, ionization of the molecules separates electrons from them, leaving positively charged electron holes behind. So almost the same with the amorphous selenium, no direct radiography. However, a layer of microscopic electrodes beneath the silicon is given a negative charge. Okay? So same pa rin sa direct radiography. So may negative charge dito so that it can attract the positively charged electron hole. Okay? And then, however, ang difference na lang nila is the dielectric layer na siya dito. Hindi na siya yung top electrode. Okay? But still, it can attract the electrons towards the dielectric layer. Okay? The electrons drift toward the dielectric layer and the positively charged holes drift towards the electrodes. This drift actually consists of a series of electrons moving up to fill each vacancy in the molecule above in sequence such that the vacancy itself, the hole, appears to drift the opposite direction. When a hole reaches an electrode, okay, it pulls an electron from it, creating a positive charge on the electrode, which can be measured by the circuit. Okay, so ulitin ko ha, light enters in a CCD or CMOS. Okay, and then when that happens, the semiconductive silicon in this area will occur an ionization event. So we all know in an ionization event, seems a direct radiography, it will create ion pairs or electron hole pairs or an electron hole pair. Okay, so one is the electron and the other is the positively charged atom. So si electron, it will drift upward into the dielectric layer. Si positively charged atom will drift down in the electrode. Okay? And then si electrode, it will remove one more electron from the positively charged atom, which will create a positive charge with the electrode. Okay? And then each electrode is connected to a storage capacitor and a thin film transistor gate. Okay? So same pa rin, may TFT gate sila and then meron din silang storage capacitor. Rows and columns of these TFTs form an active matrix array, and the electronic signal as it drains from each row is boosted by an amplifier. So same lang, when the voltage is enough, okay, it will travel towards the TFT, and then the TFT will then transfer it to the amplifier, and then the amplifier will amplify or will increase the energy of the voltage, and then of the electric signal, and then it goes to the ADC for what they call this conversion of the analog signal into digital signal. Now we go with CR. So for CR, in the CR reader or processor, an automated mechanical system uses suction cups to remove the PSP plate from its cassette, then moves it by a series of rollers into and through the area where an oscillating mirror deflects the laser beam to move rapidly across the plate, causing it to release its stored latent image. Okay, so first, suction cups muna. Okay, suction cups, it will remove the PSP plate from its cassette. Okay, so this is the PSP plate, natanggal na siya from the cassette. Then it goes through a series of rulers like this one, and then through the area where an oscillating mirror deflects the laser beam. So if this is the laser source, it will project the laser here, and then this polygonal mirror or oscillating mirror will deflect the laser beam into this area here, okay, in order for the electrons to emit visible light. Okay, so the laser beam is circular in shape with a typical diameter of 80 microns or 80 micrometers. Okay. The crosswise direction in which the laser beam scans across the plate is called the fast scan direction. So your the crosswise direction in which the laser beam scans across the plate is called the fast scan direction. So as this moves man good from crosswise. So from this area here, then yan, paganyan siya. Okay. Whereas the direction of the plate itself is moving through the radar is called the slow scan or sub-scan direction. So it is opposite from each other. So see, laser, it moves from side to side, and then see sub-scan direction or the direction of the plate is from up, pababa yan siya. Okay? The visible light emitted from the PSP is directed through a light channeling guide, a photomultiplier tube which records and amplifies the signal. So there are some light channeling guides here, or the fiber optics, no? Or light optics that will guide the light towards the photomultiplier tube. The conversion of the phosphorescent light from the PSP plate into digital data is a two-step process that is accomplished by changing light into an electric signal and converting this into digital data that can be understood by the computer. So, two-step process, changing light produced by the electrons in the imaging plate or in the PSP plate into an electronic signal, okay? And then the electronic signal, it will be converted into a digital data which can be understood by the computer. Okay, the first step in which the light is converted into an electrical signal is performed by the photomultiplier tube, or the PMT, or the PM tube. The PM tube consists of a photocathode plate attached to an electronic amplifier. The photocathode is a layer of material which releases electrons when light strikes it through the photoelectric effect. Okay, so an example of the PM tube is on the next slide. So this is the photocathode. Okay, once light interacts with the photocathode through photoelectric absorption, it will release electrons. Okay, a light photon is absorbed by a loosely bound outer shell electron. So pag ma-absorb ni electrons ang light, no, the electron will be emitted from the atom carrying this extra energy. When the laser beam in the CR reader stimulates the PSP plate, The visible light emitted from it is directed through a light channeling guide onto a photocathode layer on the input side of a PM tube. Okay, so once the PSP plate releases light, it will be guided by the fiber optics light channeling guides towards the photocathode, and the photocathode converts light into electrons, and then this electrical signal manggo na ma-produce of the electrons is too small to be detected by most other types of electronic devices. So it needs to be amplified. So in order para mag-increase ang kanyang strength or energy. Okay, so this is accomplished by through a series of a dynode plate. So these are dynode plates. Ayan po siya. Okay, each collision of an incident electron with a dynode plate releases about 5 electrons from the plate. So from the electrons here, pag magtama siya dito sa dynode plate, it will produce more electrons and then more electrons, more electrons, more electrons, increasing the energy of the electric signal or electronic signal. By having the electron beam pass through the 10 to 12 of these dynodes in succession, sunod-sunod, the electronic signal can be amplified by more than 1,000,000 times. So from this small electronic signal produced by the photocathode, it is then amplified or increased by the dynodes into 1,000,000 times. Once the imaging plate has been scanned, it continues to move into the subscan direction towards the eraser section of the CR processor. In the section, the PSP plate is exposed to bright white light, which removes any remaining information from the plate so that it can be reused. So again, di ba, we have 4 steps no, sa CR. So the last one was erase. So when we erase, bright white light is produced by fluorescent tubes in order for the remaining information from the plate can be removed again, so that it can be reused again. Excuse me. The clean image plate is now reloaded back into its original CR cassette, and after the plate is reinserted into the CR cassette, the cassette is moved to the output tray of the processor for retrieval. So after na ma-erase ni PSP plate of the remaining electrons, no, emitted light from the electrons. So, after the PSP plate has been cleaned, no, kumbaga, or erased of the remaining information, it can now be used again. Okay, so after that, the imaging plate or the PSP plate is returned to the cassette, and then cassette is removed from the reader. The entire reading and erasure process normally takes about 90 seconds to complete. The properly erased PSP plate can be used 1,000 times. Okay, after the analog signal has been produced by the collecting elements such as the TFT, the CCD, CMOS, the PMP, or the photodiode, the ADC or analog to digital converter will convert the analog signal into digital signal. Okay, so doon na siya mag-end, and then the computer will then process the signal, detect a signal created.